So the first session was more about the inner workings. The next session is more about very quick tips and tricks that you can use, like something which is kind of like no-brainer, like if I see this, what to do? If I see this, what to do kind of scenario, right? So let's actually start on that. So I'm gonna start with the introduction. Since I've already talked about it, I'm just gonna go directly to the next slide. So one of the things, as I just mentioned, so we do support basically 5 major versions of Postgres. We support all the way, actually we were supporting till recently 9.3, and we support all the versions till 10. We allow an instance to scale up from 1 vCPU to 96 vCPU, so it's kind of pretty good range of size that you can select. We support up to 32 terabytes. This is kind of like just doing a summary that I've talked in the previous slides. We do support multi-AZ for high availability up to 99.95%. We do support encryption at rest to kind of meet your compliance requirements. Some of the other features that I've not talked in my earlier presentation is one of the new features we do support is start and stop of instances. Now, if you think about it, is like most developers will come in the morning at 9 a.m., work till like 6 p.m., and then go home. You don't really need to be paying for the instance when you're going home. So we now actually support a stop call on your instance. And once you stop the instance, you're actually not paying for it. So essentially what it does is it shuts down that instance, and then when you come back, it will kind of like start that instance back up and allocate an instance. You can stop an instance up to 7 days, after which it will typically start the instance back up to run like the regular maintenance commands on it. So that is one thing, right? As I mentioned, I think RDS has actually done a great job on extensions. With 60 different extensions and I think 5 different plugins that we support, we have actually kind of like one of the wider ecosystems of Postgres already supported on it. We also support Postgres in what I call as preview environment, and I'll talk more about preview environment in the later slides. So looking at some of the new extensions we just supported in like last few months, right? PGLogical is an extension to do logical replication from 9.6 version. So if you know Postgres 10 supports native logical replication, what that will allow you to do is you can replicate from an instance of version 10 to another version 10 instance, or maybe 11. But what about the customers who are already on 9.6? So what we have done is we have enabled PGLogical, which would now allow you to kind of use PGLogical to do a logical upgrade from 9.6 to version 10, and then you can use native logical replications for your future upgrades, right? The PGLogical can also be used if you have on-premise Postgres that you want to replicate into RDS, or the other way around, like you want to kind of replicate an RDS Postgres instance to an on-premise, then you can use the PGLogical or the native logical replication out there. Some of the other common extensions that we support are PG similarity. So like people who are doing like machine learning, who want to kind of find similar words, kind of algorithms. There is an inbuilt extension that does some of the work. We have started to support that. We also support Aurora FCE. So for people who are migrating from Oracle, the typical first question is their application is doing select version from dual, because everybody in Oracle has been taught like there is a table called dual to always use, right? So the Aurora FCE extension allows you to kind of do the most common Oracle front-end compatibility out there. So your application does not need to be changed too much from your previous usage of Oracle. And also other extensions that we have recently supported is prefix. Like prefix allows you to do kind of like number comparisons, like telephone numbers and others out there. And like I mentioned, if you have more extensions that are not supported and like us to support it, there is an email alias like RDS Postgres Extensions at Amazon.com that you can actually, extensions request at Amazon.com that you can send out. Or just after the session, I can actually give you my email ID for that. Right? So let's kind of like do a quick tips to do, right? Say, for example, the first thing I talked about, like, if you're using security groups, I've talked about this example already. What you don't want to do is really kind of like add each individual clients into your security group. You want to add them into a different security group and add the security groups out there. One of the ways you should be doing it is you should take all your QA into one security group, all your productions into another security group, and when you deploy, you would add the production security group as part of the deployed instance security group instance. This will now help you to avoid cross-wiring mistakes that your application may be doing. Like sometimes, like, you have like hundreds of instances running, and somebody connects to the wrong database and run operations on them and starts deleting data, right? That can happen. So one way to kind of prevent them is actually for each of your environment, create security groups, and when you deploy them, make sure you have the right security group assigned to them. This is a very simple way of kind of like segregating who connects to your database and kind of avoids accidental connections and modifications of data, right? The second tip I want to talk about is scaling. So one of the nice things about RDS is storage scaling is a zero downtime operation. There is a performance impact, but it doesn't kind of disconnect your connections already out there. So if you're getting to a storage full scenario, like you should typically set up an 80% usage alarm on your database size. As soon as you see that, you can actually request, say, bump up the size. You can do that online. You don't really have to take the database down for it. On the site, like one of the things you need to be aware, if you're changing the instance type, you're going from, say, 1 vCPU to 96 vCPU or super large size. That is a downtime instance. Essentially what it does, it takes your instance down, deallocates, and assigns a new instance behind the scene depending on your type selected, and starts the instance again. So you could actually schedule them during maintenance window. So if you look at the modify calls, when you do a modification, you can say apply immediately or apply at my next maintenance windows. So using this scaling operations, if you schedule them for your maintenance windows, it is very useful for you if you're planning to do like month-end reports or other things. Like you can schedule them like, hey, I'm going to start on Monday with a month-end report. I need to bump up my resources for that. You set your window to be Friday and set and scheduled operation to be done during your maintenance window on Friday to bump up to a bigger size. So you could actually do that with that. So scaling essentially can be kind of controlled using either the online feature of storage scaling or using the maintenance window operation for your instance scaling out there, right? The third thing is, if you are not using automated backup, you should always be using automated backup. One of the advantages of using cloud formations and everything is like everything is now very simple to run. One of the disadvantages of making everything simple is like somebody can run a script and start deleting data also, right? So some of the ways you would actually be helpful is always have like automated backups. The advantage with that is anytime an instance is deleted or that, you would always have like a snapshot copy so you can restore from that quickly. If you disable the backups, there is no way you can regain the data back. Now, point in time only works with automated snapshots. So if you need a window up to say 7 days of having the ability to do point in time, you need to have the backup window set up to 7 days. Otherwise, you can only do the point in time between the window, the days of retention that you have out there, right? I've already talked about multi-AZ. So multi-AZ is like a one-click operation. If you need like a higher availability for an instance, you basically run the operation. You would get like about 99.95% SLA on your multi-AZ instance, right? I've also talked about read replica. So read replica can be used to kind of scale your storage and offload your workload out there, and also for cross-region. One of the things I didn't talk much about it is the outbound access. So Postgres has a rich foreign data wrapper technology. In RDS, we already support the Postgres FTWs, right? So what you can do now with the recent feature that we have added is you can set up foreign data wrappers on your primary instance and then let it replicate to the secondary. And then you can do a read query for your analytics along with the foreign data wrappers from your read replicas. So that way, you can completely offload all your analytics query to your read replicas. So that was a feature which was added like about 5 months ago, which would allow you to kind of now do full FTW from your read replica. I've also mentioned for DR purpose that you have the ability to kind of like do a protected read replica with multi-AZ read replica. So you are able to convert it to a primary instance very quickly, right? Another feature, and I think this is again introduced as a lot of people start using cloud formations and other things. We have like a new feature enabled very recently to make sure that if you mark a database as delete protected, then it will reject delete request coming from the CLI. So anybody who is doing like an automated CLI based on some scripting, if they try to delete the instance, they would basically, it will get a failure out there, even if they have permissions. If you really want to delete, what you could go is you could go into the console, and uncheck the delete protection, and then you would be able to delete it back. And this was actually introduced like as more and more people started using cloud formations. In the early days, like when you delete your stack in cloud formation, it would also, if you by default don't mark it to be protected in your cloud formation, it will also delete your database. So I think this feature kind of helps delete accidental deletes. So in CloudFormation, you now actually have the option, like when you delete it, you have the option to say, do not delete your database also. But like if you miss that, this is an additional protection that can help you save the database out there. Right? The tips for doing minor version upgrades, which I've already talked, is like, you always upgrade your read replicas first, and then do your primaries. Now, one thing to keep in mind for minor versions, you don't have to wait to the next minor version. You can actually skip minor versions and go directly to the latest minor version upgrade. So say, for example, you are running on 10.4, and there is 10.6 available now. You can actually do a minor version upgrade directly from 10.1 or 10.4 directly to 10.6 and skip all the intermediate minor versions upgrades out there. I do highly recommend people should be running on the latest minor version available, or at least the preferred minor version available that is running, because most of the time the Postgres community does do security fixes in between them, the minor releases, and only way it will apply to your instance is when you upgrade to the latest minor version of your series that you are using. As I mentioned, minor versions can also be orchestrated using the scheduled maintenance operation. So you can schedule a minor version upgrade and say, schedule to be done automatically at my maintenance window. And when the maintenance window comes, it will actually upgrade it. And basically, you don't have to kind of babysit it. If you remember it right now that I need to do it, just schedule it. And during the maintenance window, it will be actually upgraded for you, right? Anybody still using Postgres 9.3? Okay, I'm happy. So community has ended support for version 9.3, and we have also ended support for it. If you're using 9.3 anymore, it is kind of like unsupported now. And you won't be able to create like new instances anyway soon. So if you're running 9.3, you should start upgrading. Later this year, we'll also start deprecating 9.4. So if you're running 9.4 also, you should start moving ahead. Typically, the recommendation is like you should at least upgrade every 2 to 3 years if you're running on a major version, which is like older than the current one. One of the new things which was introduced during reInvent is recommendations. So what this recommendation thing does when you log in, it kind of gives you an overview of all your RDS instances and say, hey, these are the instances where you have OS patches available. I mean, OS patches still needs to be applied to some degree. Most of the OS patches apply automatically, but there could be some where it may actually require an opt-in from the customer. So you would actually see like there are patches available for your instances out there. If you're running an outdated minor version, the recommendations will prompt you to kind of like, hey, you are actually running a older minor version upgrade. We would like you to upgrade. The advantage of using recommendation is once you come to the screen, you can see them. There is a one-point click to kind of apply immediately or schedule it in your maintenance windows with that, right? I talked briefly about this before. If you want to kind of migrate, upgrade from RDS Postgres to Aurora Postgres, and typically your reasons is like Aurora Postgres supports like 64 terabyte compared to 32 terabyte, and you need like the more of the concurrency improvements in RDS Postgres. The way you would do that is twofold. You would either do a snapshot and restore the snapshot directly to Aurora Postgres. A typical recommended way is you take your instance and create an Aurora with replica. So behind the scene, what it does, it takes the snapshot, it upgrades that snapshot to Aurora Postgres, opens up a replication from your primary instance, starts pulling all the changes from the snapshot and now under. It will catch up. There is a CloudWatch metric that you can actually figure out, and when you are ready, you would switch it over. Now, the recommendation is you should use this Aurora with replica from the RDS Postgres instance only for migration. If you want to do real read scaling test and other things for this Aurora instance, you should create an independent instance of this Aurora, like you promote it, create more read replicas from it, and then you can run your workload to see the improvements that you will get with it. With that, right? The next things I want to do is like, these are kind of like the basic things. Like the next few things I want to talk about is like a little bit more detailed. So I'm kind of like calling it tricks and not tips. And tricks would be like, you will have to do some work to kind of do that, right? So an often thing that people question is like, how does read replica work, right? Now, one thing to keep in mind is read replica has a trade-off. Like, if you want to be very fast following your master, then you cannot have queries which can slow down that replication. And if you want queries that can actually, long-running queries, then there are certain operations that may not apply on your read replica. So understanding that trade-off, and you have to make a call to say, hey, what is the importance of this read replica to me? Do I need to be a fast follower? Or am I really using it for like month-end queries, which are large analytical queries, which can actually have, it is okay to kind of have some lag, but I need these queries to finish, and it may take a long time. right? So based on that, there are certain parameters you can set to say, do I want to do fast follow or do I want that queries to run, right? So before that, like there are quick things you can do. One is you bump up wall keep segments. By bumping it up, if the replica is not catching up, and say for example, it actually had a glitch, and then when it starts again, it can come to it and it will find all the logs are still there on the master, on the primary instance, and start streaming on it and catch up quickly. By increasing the wall keep segments, it will find those logs out there. If it doesn't find the logs on the instance itself, nothing is lost. There is still a way to kind of get the logs because we are protecting them through your backup windows anyway. So it will go to the backup location and get the log files and still apply. But that method is a bit slower. You will be able to do that, but it will take more time to consume on it. So if you want to kind of like quickly catch up, bumping up wall keep segments help you. The other way is actually turn on compression for your logs. So what it does, it compresses all the logs before it kind of streams it out to your replicas. And that we have seen kind of like helps boost the performance because database data seems to be highly compressible, so you can actually move them quicker through the pipeline out there. So there is benefit out there. You can also kind of like increase your checkpoint. So the advantage of doing checkpoint is like the end of checkpoint is like a forcing function that everybody needs to catch up. So it kind of like wants your queries to be done even on your replica, right? So by stretching the checkpoint timeout, you can allow your queries to run longer also. That said, there is actually a feature also called the hot standby feedback. So what that does is like anytime you run a query on your read replica, it sends information about that table to your primary instance. And the primary instance will not vacuum data on it till that query is running. So the advantage is like your lag between your replica and your primary is kind of reduced because it doesn't do any queries that will be blocked on your replica. The disadvantage of using that is because you're blocking vacuum, there may be a bigger bloat on your primary, right? So again, I said, everything about replica is like, you're thinking about doing the trade-off between, do I want it to be a fast follow or do I want to optimize it for running the queries on it, right? So using this, like if you want the fast follow, you would actually turn it on, make sure they are tightly synced up all the time, and you can actually get your replica to be pretty close to your primary out there. On the flip side, if you want to kind of optimize it for read replicas, what you would do then is you would actually bump up the parameter called the max standby archive delay and the streaming delay. Now, by default, in various configurations, you will see, like, depending on the version, it may be set to -1, which means it will allow the queries to run all the time, or it may be set to 30 seconds, which means if a query on a replica runs for 30 seconds or greater, and it's holding transactions or the replication logs to be applied, then it will kill that query, right? So if you do not want that to happen, you would actually bump up these variables out there. And depending on the type of queries, you know best like how long you should keep it out there and use that as the same time to keep it. So like I said, just to kind of reiterate, and this is kind of important, like if you want to understand how to optimize your read replicas, first of all, figure out, do I want it to be a fast follower or do I want to optimize it for queries? And then use the parameters to kind of figure out and optimize it for that particular situation. Oftentimes, I also say that you don't have to kind of compromise. You actually create 2 read replicas, one for fast follow. So if you want to use that as your DR strategy to kind of migrate, then create a dedicated fast follower and create another read replica for running the queries. And that can actually have a lag independent of it. So that is another way you can also do that, right? The next trick is about doing major version upgrade. Now, one of the things I did mention is oftentimes when we do major version upgrade, one of the things I did not mention in my earlier slide is when you do a major version upgrade, RDS will do 2 backups for you automatically. one before it starts the major version upgrade, and one after you finish it. The reason for doing this is, during major version upgrade, there is no point-in-time recovery. So in order to make sure that you can always recover your data at that end point, it will always do a snapshot. So if your backup, if your upgrade fails, it will go back to that starting point. Similarly, after upgrade, before starting your point-in-time recovery, it will need to do another base backup, which means after upgrade, it will do another backup again, right? Now, backups in RDS are incremental, which means the time to take backup depends on the changes on the blocks that are happening beneath in the file system. So oftentimes when you are doing major version upgrade, if you have not taken a backup for a while, as soon as you initiate it, it will do a backup, and the first backup typically may take longer time out there. Now, sometimes if you only have like an hour to do your major version upgrade, then it will be very hard to kind of finish that whole operation in that time frame, right? So one way you can actually do that around is, you could, oftentimes, like if your backup windows are very tight and you want to make sure that you can finish within that time, what you do is you take a read replica of your regular instance. Once it has caught up, now what you would do is, like, you would say, I'm going to do this process. I'm going to stop the workload on your primary, keep it out there, promote the read replica, and when you're promoting, you keep your backup 0, so it doesn't start the backup, and then you do immediate upgrade. Because the problem is, like, if something goes wrong, I'll discard the whole environment and go back to the original. But if everything finishes, I can actually finish my upgrade pretty much quickly without waiting for the backups. And once the upgrade is finished, that's when I turn on the backup. And then the backups will, and backups can happen automatically behind the scene for you. So while the backup is happening, you can now actually move the workload and start using it. So that would be one way to kind of making sure that you can actually meet your window requirements while doing a major version upgrade. So this is kind of like a neat trick. Especially, I think one of the reasons we were working with some customers who really wanted to kind of cut it down to like 20 minutes and so, and this actually allowed them to kind of do that window. And the way to do that is, like, you pre-create the read replica, let it catch up. When you come to your backup, your upgrade window, you do the stop, upgrade, and then flip over, start creating read replicas and start the backup while you can start the load again at that point of time. So you can kind of control the downtime of that, right? Another same trick, you can now extend it to a bigger thing, right? Oftentimes, it's very hard for people to schedule downtimes to do the upgrade. So in the same situation, the recommendation typically is, like, while you're doing the work to do a major version upgrade, don't stop at just one single upgrade. Do a back-to-back upgrade and go to the latest preferred versions, like major versions. So if you're running 9.4, you may want to go to 10 now, or 11, or like whatever is out there, right? So like you would want to do your 9.4 to 9.5, 9.5 to 9.6, and 9.6 to 10, and come out there and use it and do it one shot. Because every time you skip a major version upgrade, you will essentially get 2 or 3 more years of life in it, right? And you want to kind of reduce the number of times you are doing this major version upgrade to once in every 2 to 3 years. So this would actually help you to do that. Using the same strategy, right? Like you can actually kind of like bring multiple of this down to like an hour and get like 3 versions upgraded in roughly about 1 to 2 hour time frame as such, right? So that's a trick about like how do you kind of optimize the upgrades. Another trick that I think I've mentioned this, but I'll just reiterate quickly, is like you could use PG logical replication in and out of RDS onto on-prem. So there are 2 different ways you can do right now. One is using PG logical. One is doing native logical replication of Postgres 10. And then you can also use DMS as another way. But like if you want to use like pure Postgres protocol only, then this would allow you to kind of move your data from older version on-premise into RDS and back, right? I had talked about IAM authentication support. Like you can actually now use IAM in conjunction with the database users. A little bit more detail on how you could actually simplify that life for you, right? When you create a user in the database, you're giving that user RDS IAM as a way to say, hey, this user will be now connected by an IAM role. The trick is use the same user in your IAM also, call it the same username, and do the policy mapping using the name. So then your clients do not have to change their usernames. So this becomes kind of critical. Like in your application, what you do is use the same username. Instead of password, you will just add an additional call to get credentials for that password from IAM and pass it through the password field of JDBC field of password in your code, and now you have kind of like integrated into getting your application using IAM completely without ever having to rely on the passwords or storing that password in your applications, right? Another thing we added recently is like we find like a lot of enterprises are now using their own password manager to kind of enforce password compliance, right? Like recently I've heard like enterprises are forcing users to change password every 180 or 90 days. Enterprises are enforcing like the password needs to be certain characters, minimum length, maximum length out there. So we were getting a request for like, how do we do that on RDS Postgres? So one thing we have enabled is like, we basically said, hey, what we will help you is, Postgres has limited capabilities on how to handle passwords complexity. But what we can do is we can give you an additional feature where we disable the password feature for an individual user in Postgres. So with this new feature, if you enable it, a user can log in, but they cannot change their password on their own. So this would now allow a centralized password manager to make the changes on behalf of the user. So if you're using like a homegrown password manager or something, now it can actually very easily integrate with RDS. So what you do is you create a new user for your centralized administrator who can change passwords on behalf of the users in the Postgres database. And the way you would do that is for that new user, you will give them two roles. One would be the RDS password role, which would allow it to change passwords, and also a role of create role, by which it would allow it to change password for other users. So by doing that, now you can actually create like a centralized password manager with your own complexity rules that you can enforce on the database. And users will not be able to change password behind the scenes in the database itself. So that the two fields that are restricted by this feature is like the password field itself and also the expiry of the password, which now the user doesn't have control. And that can be done by an homegrown password manager out there. So oftentimes, like if you hear, like, hey, I want to do like a password complexity management in Postgres, you would enable this, take out the password change capability of all the users, and just write like a small program through which you can update the passwords in the database. Right? The next trick is like doing performance tuning on RDS, right? I've already talked about performance insights, where it gives you a running capability of how your queries are being executed. A couple of things that will help out is if you enable pgstat statements, you will see more information out there. Another thing you could do is in pgstat statement is to bump up the SQL size that it stores. It would help you to kind of like show bigger SQL queries in your performance insight. Thanks to the usage of ORMs, the queries are getting bigger and bigger, which are hard to understand by human eye. And unfortunately, those queries need to be shown completely to make sense in your performance metrics also. And the only way you can really do that is like if you bump up the size of SQL query that is stored in pgstat statements, so you would see that properly. The thing, if you have not used pgstat statement, is it's actually nice to kind of use it by itself also. So if you, the way you would do that on RDS is you would preload the library using the shared preload libraries. And for the database that you want to kind of monitor, you would create the extension pgstat statements. You could actually typically do that at the Postgres level, and it will track all database queries anyway. And then you can run the SQL queries directly from your pSQL client also. Performance Insight behind the scenes uses this metric along with the wait events behind the scenes and kind of does a correlation for you. Another useful plugin for that is the auto-explain module. If you have not used auto-explain, what it does is like it kind of waits for an event. If the query is beyond a certain threshold, it will automatically dump the query plan in your engine logs. And this could be useful, like where in some cases your logs are changing, right? So this would actually help you to kind of log specific queries only when they are slow. If you're using stored procedures, you also want to do log nested statements turned on, and that will actually throw the queries within your stored procedure also in the log. So you can actually, this is the only way you can actually debug stored procedures right now, right? Like to find out which SQL line in your stored procedure is slow by using the auto-explain and turning on logging of the nested statements, right? Few of the final thing I want to talk about, like if you're using connection poolers, make sure that you size the number of connections properly. One of the things you really want to use is the max age capabilities of your connection poolers. Depending on what you use, like C3PO or PG Bouncer, make sure to kind of recycle your connections. The way Postgres works is it uses workmem to do any sorting activity. But if your connections are being reused by your connection pooler, it doesn't free up the workmem from your process. The workmem is only freed up when the process dies. So by using the max age, you will recycle the connections and it will free that workmem back to the system usage. Otherwise, what you will see is like, if that same query is now running on the different connections, it will start bloating up every connections, every session that is being used in that connection pool, and doesn't really buy you anything. So kind of like, keep an eye on that and use that. Two last things is, bloat management is definitely something that you need to be aware in Postgres. The default vacuum does a good job, but you do want to kind of like, every now and then make sure you do a vacuum full to kind of release the space out there. So if you do large deletes and you do a vacuum, it doesn't free the space back to the operating system. The only way you would do that is when you do a vacuum full. In order to kind of help out, like vacuum full is kind of like a table level lock. So it will impact all your applications or connections that are running on it. So we also support PG repack extension. So if you're kind of worried about the time it would take to run an occasional vacuum full, you can actually enable PG repack and use repack to kind of remove the bloat from the table. Repack still takes a table level lock, but for a very brief period of time, and then it would be able to kind of quickly release it and allow you to free up the space behind the scenes. So this is useful for a 24/7 type of category where, I cannot really take a downtime to free up my bloat. You want to use PG repack at that point of time. Right? And probably the final thing, I'm guessing you should be aware that Postgres uses a 32-bit transaction ID, which means like it has a floating window of 2 billion transactions. So occasionally, if you have a transaction that is not allowing it to be freed up, you may hit the transaction wraparound problem, like when you get close to 2 billion transactions, right? In RDS, we actually throw an internal ticket if there are instances out there. We actually do then initiate a customer reach out from our own point. But the ways to avoid that is you kind of like keep an eye on what is holding your vacuum to be applied. Typically, if you have large tables, you do want to kind of, make the auto vacuum more aggressive so it is able to keep up with your vacuum. With that, we are pretty happy to serve all of our customers. Many large companies are already using RDS Postgres for their critical workload. We would like to get more of you to also join this team. Okay, with that, thank you very much.
Thank you very much. Before there will be questions, I'd like to remind you two things. First, there are still stickers, $50 account, they are here and over there. You can take them if you need. I'd like to remind you that you can sign up for quick presentations on the information desk. You can register there, and also on the website you can vote for the presentations. And now questions to the speaker.
Question, I know I'm here. Sean Debnas from Amazon some time ago was working on moving a simple LRU of Postgres cluster to buffer cache. Is this work still going on? And
no. Please answer.
Yeah, I didn't get the question. Can you repeat it?
Sean Debnas from Amazon was working a few months ago on moving SLRU cache of Postgres to buffer cache. Is this work still going on, and how?
It's still going on, and I think in some formation, what we call as like the cache failover is actually available in some instances, but there is improvement going on. So. The way Aurora Postgres works is like the buffer cache is slightly different than standard Postgres, where standard Postgres relies a lot on the file system cache. In Aurora Postgres, it is part of the Postgres buffer pool that it has. And when a failover happens, it will take the cache along with it to the replica failover instance.
Okay, thank you. And do you plan to push some advancement from Aurora to upstream to vanilla Postgres?
For some of the features, we are looking into it, and we'll be working with the community on how best to kind of do that. Those features are kind of like looking into it, like what would make sense for the larger Postgres community to be used for that.
Okay, thank you.
Thank you very much for great presentations. I have a question on behalf of my colleagues. Apart from Landis Bookard not working tool in the DMS type, when it is possible to make a normal replication on AC2 and not a logical replication?
If you want to kind of move to EC2, the logical replication would be the way to do it. For the physical replication, it is only used for between RDS to RDS instances. So you can use create read replicas, snapshots, and snapshot restores to kind of do that. Now you can take a snapshot and move them across accounts, but it would still be within the RDS environment.
Okay, thank you.